We're just going to do lenses. Last day we did mirrors. A lot of similarities. A couple differences, obviously. Anyone have some lenses? You do, yeah? Quite a few of yous have non-perfect vision. Can you have better than perfect vision?
Yeah.
Lewis says yes. Do you agree, Shelby? Yes, you can. And get this. My wife had laser eye surgery 8 or 9 years ago now. Okay? And she walked in, she was about, I don't know, 220, 200. I'm not an ophthalmologist or an optometrist, and I still don't know the difference. But anyway, she had terrible vision. She basically couldn't get out of bed in the middle of the night without putting her glasses on and go to the bathroom. Okay? Otherwise, she'd wake me up by hitting something. She went in, paid $3,000. We went to the best guy you could possibly go to. Put her in a little chair, pulled out a scalpel and went zip, lift up the flap of her cornea, put in a laser and went zap, 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 zap. Did the other side, and I got to like page 1.5 of the magazine in the waiting room. She walked out and said, "I can see you." Took a little while to heal. You got to use these drops to make sure your eyes heal properly and everything else. But she walked out of there with 20/15 vision. Okay?
You have to be awake when you're
She was. Yeah, absolutely. But best 3,000 we ever spent.
Did they do them both?
Yes.
That's not common.
No, that's what they do.
They don't do that often.
Well, I don't know what some other people do, okay? But I know we went to see the head of cataract surgery at UBC. He fixes other people's problems when they make mistakes, other guys who do people's eyes, and you sign a waiver before you go in. You're not allowed to sue him if something goes wrong. This is the guy who tries to fix them, okay? That's who we went to see. Was it more money? Yeah. But when you're talking about, here's the funny thing. Carmen here goes out shopping for purses, and she price compares 12 different places, spends 6 hours, and oh, this one's $10 cheaper. I'm going to drive 18 miles to save $10. And then people with their eyes see an ad in the paper, $2.99 an eye. Oh, they're in there in 10 minutes. Yeah, I do need. Really? This is the only pair of eyes you got. As far as I know, you can't do eye transplant. Maybe in experimental medicine, but I just don't get it. Anyway, how much was a pair of glasses? My wife's about $400 to $500 or $600. She would have gone through about 4 or 5 pair by now. We've actually made money by spending the $3,000. Not to mention the convenience of never having to worry about your glasses again. So it's been almost, I don't know, 8, 9, 10 years now. She's still 20/20.
How does the number ratio
If
higher, better?
Yeah, higher is worse. Now a hawk basically has that vision. They can fly up in the sky, way up there, so you barely see him, and he can pick out a mouse running in the grass in the field here. That's how far they can see. So it's like 2, not 20, right? I think I got the numbers the right way. Yeah, okay. So if you got bad vision, she was like that, I don't know. Really thick glasses, right? And she had contacts. And like I say, what you spend on that over 10, 20, 30 years, huge. Thousands and thousands of dollars, right? So, anyway, I didn't plan on going there, but I did. Lenses. Even if you have 20/20 vision, you got a lens in your eye. We're going to talk about that in a sec. Now don't freak out. We're not doing all of these. We're just looking at this one and that one. Did we do convex and concave mirrors? Yeah. And the only other kind's a flat mirror. There's different curvatures of each, but basically you got 2, okay? We're not doing all this funny piano, concave, plano stuff, okay? Now, this isn't actually in Science 8. Which one's in your eye? Is it this one or is it that one? That one. Which one's that? A or B? B, you bet. Okay, good. You remember that from Science 8? Or did you learn that recently? Oh, you guys cut them open, didn't you? Okay, good. Was it sheep or cow?
Sheep.
Yeah. And you actually saw it and you remember. See, that's the beauty of hands-on learning. You remember. You felt it, saw it. It was there in your hand. It was, yeah, and probably stunk too, right? Okay. So, what we're going to do is some of this. Drawing the images that these lenses produce. Converging, and that's what you want in your eyeball. You want to converge those light rays, guys, to focus on your retina so that your brain inverts that image and you see things right side up. It's kind of all backwards. Okay? That is convex. You see how this one kind of makes a cave, just like our mirror? That's concave. It diverges the rays. Okay, but first let's start with convex. And the same rules. A ray that comes in parallel to this, it actually refracts on this surface, and then it refracts on that surface again, but for simplicity's sake, just pretend there's an imaginary line halfway through it, and it just hits that, and refracts down, and what's F stand for? A focal point. There's one here for this curvature, and there's one there for that curvature. This is the one we're concerned about. A second ray comes from this focal point and then refracts parallel. Okay? Same thing we did before. We had two rays with a mirror. One comes in parallel and reflects through F, and the other one goes through F and reflects parallel. Same thing. But we got a third one for a lens. If it goes through the dead center, again, it actually refracts here, and don't quote me on which direction, and then it hits here and refracts back, but essentially it just goes straight through in one line. Okay? So if I want to draw this thing, and then there's one question in the book, so I can't do it, so I got to do my own. So right here, there is convex lens. Here's our principal axis. We have F here, and we have an F out here. We don't really care about this one. If this is where our image is, make it a little smaller than your lens. Here's how you do it. One ray comes in parallel, refracts through F, make it nice and long. Okay? And the other one that will come through a light ray going through F appears to hit this thing and go parallel, but we don't really care about that one so much. We care about the one from the tip that goes this way. And one that goes through F, let's draw it, goes parallel. You see where those two line up? That's where the image will be. But let's do one more. And this one you might need to fudge. But there's one that goes right through the center. Just make sure it lines up right where those other two do. Okay? That's where the head of this image will be. Now where's the bottom? Again, one that goes through F, goes parallel, or you can think of it, whatever goes along the principal axis stays there. So that's where the bottom is. This is where the top is. So this thing must be inverted. That's where the image is. Okay? Using those three rules. That's convex or converging. Let's look at concave or diverging. Let's start down here. One that also goes through the dead center just keeps going through the dead center. one that goes parallel actually diverges away, but it looks like if you were sitting over here, there's your eyeball, it would look like it came from F, the focal point. Okay? Also, one that is aimed towards the second focal point will diverge and go parallel. So it's basically the two same rays we had before, but it's a little different with a lens. Okay, using those three rays, how would we do this guy? And do yourself a nice exaggerated diverging lens. Your principal axis goes right through the center. We have a focal point here for this curvature. For this curvature, we have a focal point there. Those are the same distance away from the lens, okay? We're not using different curvatures for this lens. They're both the same. Here's your object. And where's this image going to be? Well, first, a ray that goes parallel will diverge away. And you might need to fudge this. You want to maybe do the dots first. It looks like it came from F. So if that's not perfectly straight, like I said, maybe you want to do these dots first, and then, well, that's got to be a straight line, okay? So one photon coming from the top will do that. Also, one photon headed towards this will actually end up going parallel, because that's a ray that is going to F. Okay, so this one that looks like it's going to F doesn't. It refracts and ends up going parallel. And again, if you're over here, where do you think that thing came from? It looks like it came from here. So you see where these line up here with the dots? That's where the virtual image will be. And we don't have to worry so much with lenses about real and virtual, okay? But you need to know how to do these two things on the test, or obviously you won't get the marks. There's another one. We don't really need it, but, and again, it looks like I'd have to fudge this one pretty good. One that goes through the center is supposed to line up with the top of that arrow. Okay? But we don't really need it. All we needed were those two rays, and you know where your image is. But one that goes through the center, that should be a straight line. Okay? And I'm recording this, so if you forget this, you can rewatch it again. But I'm going to get you guys to redo that there. I'll show you this too. Not just for this lesson, but for any of it. This website is a really good resource, the Physics Classroom. Every lesson in here that I've done, Physics 11, they're in here. And if you want to see other pictures or learn how to do it, well, this is exactly what I just did. Okay, feel free. Really, really good resource. And even if you go to university, make note of this webpage. It'll help you there too, if you're taking science first year university. Okay, Physics Classroom, good stuff. So, what else? Well, we also have an equation for lenses. But does that look kind of familiar?
Yeah.
Yeah, it's the same one. Okay, you've already been working with it. No difference, no change. DO stands for object distance. The distance from the object, from the lens in this case, not the mirror, right? DI is the image distance, and F is the distance of the focal point or the focal length. There's one in your eye, there's one in a camera, there's one in a telescope, etc., etc. Focal length. Okay, let's look at the ball. In grade 8, you should have memorized every one of those terms. We are not going to do that this year, but you should kind of know it. Obviously, light comes in here. Here's the muscles that when you read, you strain a lot because you have to use them to make your eye focus on something short away. If you get a headache, like my daughter does, because she reads for like 17 hours straight, well, give yourself a break and focus at infinity or something as far away as possible, because that's when your eye's most relaxed. Give it 5-10 minutes, you probably feel better, right? Because you've given these muscles a bit of a break. Image comes in. First, the cornea does something with that ray, okay, refracts it, and then your lens does, and if all's good, the image is right there on the retina and gets sent to the brain. There is one spot, did you guys do this in Science 8? The blind spot, and you try to find it, and there's actually something in the textbook you do that. If it focuses right there, that's the only spot in your eye where you don't see it. That's where the optic nerve is, okay? And you have to move it, and it's really weird. You see this dot peripheral vision, and all of a sudden, it's not there. Like you're blind in that one spot. Okay, everywhere else is good. Now, what happens if you don't have born with nice eyeballs? Then you need to get corrective vision. And believe it, there was once a time where these things didn't exist. So people walked around kind of blind. And I guess caveman died because he couldn't see what he was hunting. Right? Farsightedness or hyperopia means that the eyeball is too short for this lens. Now again, I'm not an ophthalmologist or an optician or whatever you call them, but maybe this lens just isn't strong enough for this ball. Okay? The image focuses back here, which of course is not where we want it on the retina, so it's blurry. So how do we correct that? We want to make this thing a little stronger, so we need some additional help. We need another convex lens to refract it partially, and then your own lens so that the image is right there in the retina and we see clearly. So how do we correct farsightedness or hyperopia? With a convex lens. Nearsightedness means you can see near but not far away. Myopia, well, we got to do the opposite. This eyeball, and the book shows you basically the same picture, but some people have oval eyeballs. Okay? You're born like that way, and I mean, we're not going to take it out and surgically alter it and stick it back in. That's too risky. We don't know how to do that yet. What's easier? Give you a pair of concave lenses. So we'll actually, this thing's too strong for this eye. Laser surgery would actually correct that, right? We'd slim it down a bit, so now it would be right there where you want it. But what's safer for you kids is let's diverge these rays a bit more, then it goes through this strong lens and it comes right back where we want it to. Okay, so we use a concave lens if you're nearsighted or have myopia. Now everybody look there in your book. Does it look blurry anywhere? If it does, you have something called astigmatism. And I actually met a guy once who loved planes. He dearly wanted to be a pilot. And all his life growing up as a kid, I want to be a pilot. He had toy planes and, you know, little planes and remote control planes. And then he comes up one day and gets an eye test. You have astigmatism. I'm sorry. Can't be a pilot. Basically, yeah, worst day of his life. But we basically want people flying planes to have as good a vision as possible, right? And until we can get an eye transplant, sorry, you're out of luck. They also test you for arrhythmia for your heart. You don't want a guy having a heart attack in a, you know, Boeing 767, right? 777. Not good. So, anyway, something fun to check out. Anybody have that, by the way, blurry, that you didn't know of already? Okay, astigmatism. It's an aberration in your eyeball or your lens. Basically, it's just not as constructed accurately as it could be. It's a little bit of blurriness just in a portion of it. This might all look all fine, but that one might be blurry, so it's a little aberration in the side of your eye or your lens. Okay, that's it. 242, 1 and 2, 244, 1 and 3, 252, 2, 4, 10, 11. Tomorrow will be review questions. If you want them, I can give them today. But that's it for now. But first, let's have a look at this. This will be kind of fun. Number 11 on page 211. Do that question. I got a little mirror to check. But do you know how to, like I said, when you're looking in a plane mirror, you know how when you wink your left eye, when you look in a mirror, your image thinks it's which eye? The right one. So, you know, anyone been driving and had an ambulance behind you? And it's written ambulance, and you look in your mirror and it says ambulance properly because they got it backwards on the front of the car? Yeah. That's what it says in number 11. Let's see if you can write your name so that if you hold a mirror to it, you can see it, read it correctly.
Wait.
Number 11, page 211.